Hello, my dear NEET 25 and 26 warriors. Welcome to the Vedantu NEET English channel and the next amazing class of basic maths, which is required for your NEET physics, and that is geometry. In the previous lecture, we did algebra. If you have missed it, no issues. You can still understand this class. It's a completely independent lecture. But after this, make sure you check that lecture out, which is there on our Vedantu NEET English channel in the live tab. All right. And let me also remind you that there is 70% scholarship going on for all the NEET dropper batches across India for our offline batches in the Vedantu Learning Center. We are right now in 20 plus cities. So visit your nearest center to check out the scholarships that you can get, in your dream batches for, NEET 25 if you are planning to take a draw. Okay. So that's for all the offline students, a very important notification. So my dear students, welcome aboard. This is your captain Shreyas. And hello Meghna, Sahil, Pavitra, Sujit. Hello Gokul. Mark your attendance quickly. Get everybody onto the channel. Wake everybody up. There is no time to waste. The NEET scams will happen parallelly, but our teaching should never stop. Our learning should never stop. That's the reason why we are continuing our lectures as it is, like you have seen from the past many days, right? So this is your captain Shreyas. Make sure you are smashing the like button because then YouTube understands you are interested in more NEET related stuff. So it will recommend you those things, or else it will recommend you random distractive things. And subscribe so that you do not miss any further academic class on this channel, or else you will have to keep searching. So subscribe because a lot of things are going to come up for the next entire year. Okay, so let's begin, my dear warriors. Double voice is coming. Double voice is coming. Is it? Is it? Is it? Is it? Let me see. Is it true? Is everything fine? Just check it out. Is the voice fine? I hope. Is the voice fine, guys? Everyone? Is the voice fine? Sahil, maybe just check your computer also. Maybe you have opened two tabs. Maybe you love me so much that you open two tabs and then voice is coming from both the tabs. Okay. It's fine. It's fine. Okay. Okay. So let's begin. In the geometry part, by the way, let me tell you, we are going to learn trigonometry, angles, and all the important properties regarding arcs and trigonometric ratios, everything in today's class. Throughout your NEET physics, you are going to need this. Please don't ask me when I'm teaching Newton's law, sir, how do you get this sine theta, cos theta? Sir, how did you find sine 53? Sir, how did you write this, formula? Where did this sine theta plus beta formula come from? All these things in today's class, your entire NEET physics is sorted trigonometry wise or geometry wise. Okay. Now, the first important thing is angle. Now, see, angle between any two lines, right? When I show it by a symbol theta, phi, psi, whatever symbol you want to use. Okay. So, understand you have two units of measuring it. One is degrees, like these two lines are at 90 degrees. This is 180 degrees. The other unit of measuring the angle is basically radian, and 90 degrees is basically pi by 2 radian, pi by 2 radians, and 180 degrees is basically pi radian. So this is another unit of measuring the angles. So there are two units. I will mention it over here. The units of measuring the angle is either degree, you use this symbol, or you can also use radians, Okay. So both are, used depending on what the problem is like or what the options are like. Now, this is the most important thing, that pi radians is 180 degree. Probably you should know this like by heart, and you should know this as a rule that this is always going to be true. So remember this a very, very important phrase, which is pi radian is equivalent to 180 degrees, because that will help you convert from any other angle to any other radian. So, for example, I want to convert from, degrees into radian. if I want to convert from degrees into radian, let's say theta is in degrees, I want to convert this into radian. I want to convert this into radian. I want to get rid of degrees, so divide it by degrees. Degree should cancel. So 180 is in degrees, so put 180 degrees here. Do you see degree will cancel? I want to get rid of degrees and convert it into radian. So then put pi over here. So basically you are multiplying by pi. That's it. You have converted into radian. So if anything is in degrees, divide by 180 and multiply by pi, because degree will cancel. You will convert it into radians. The exact opposite also holds true. Imagine theta is in radian. By the way, the symbol for radian, sometimes is also that top you put C. Like you put circle on the top for degrees. You can also put pi by 2 radian, or you can put pi by 2 rad, or you can also put pi by 2 and that C. That C stands for radian. Okay, symbolically like that circle over here. So if it is in radian, if it is in basically radian, my dear warriors, if it is in radian, I want to get rid of radian if I want to convert it into degree. So what will I divide it with? I will divide it with pi radians. I will divide it with pi radians. Radian will cancel and multiply it with 180. Multiply it with 180, it will convert it into degrees. As simple as that. So, my dear warriors, let's take example. Say for example, I give you 45 degrees. I want to convert it into radian. What will I do? 45 divided by 180 multiplied by pi. Come on, my dear lions, my dear warriors, what is the answer? 45 divided by 180. How much is it? 1/4. 45 fours are 180. So hence in radian, it will be nothing but pi by 4 radians. Pi by 4 radians. Is that right? Similarly, if it is 30 degrees, divide it with 180 degrees, divided with 180 degrees and multiply by pi, multiplied by pi. What will happen? 30 goes with 186 times, so this will become nothing but pi by 6 times of the radian. Similarly, if it is 120 degrees, you divide it with 180 degrees, multiply by pi, multiplied by pi. What will happen? 120 and 180, 0 cancels, 12 goes with 6 2 times, 18 goes with 6 3 times, so 2 by 3. So this will become 2 pi by 3 radians. Understood how to convert from degrees to radians? The reverse also we can try it out. Let's say somebody gives you pi by 3 radians, pi by 3 radians divided by pi and multiply by 180 to convert it into degrees. To convert it into degrees. Pi by 180 by 3. 180 by 3 is 60. So that is basically 60 degrees. That is basically 60 degrees. Somebody tells you, okay, pi by 2 radians divided by pi multiply by 180. So, my dear warriors, pi by 180 by 2 is nothing but 90 degrees. So, this is nothing but 90 degrees. Everyone with me on this? Similarly, somebody says, let's say, let's say 5 pi by 6 radians. 5 pi by 6 radians. So, divided by pi and multiplied by 180. Pi by. That's what you do when you want to convert it into degrees. Pi should be eliminated. That's why we divide by pi. 180 by 6, 30. 30 into 5, 150. So this is nothing but 150 degrees. Now did you understand how to go from degrees to radians, radians to degrees? Everyone confident? Smash the like button right away, right now. Everybody confident? Smash the like button right away, right now. Is it clear how to go from degrees to radian? If you want to go from degrees to radian, remove the degree. How? By dividing it by 180 degrees and then multiply by pi. So pi should be there in the answer. If it is in radian, divide by pi radian and keep the degrees on the top, so degrees will remain. 180 you multiply. That's the major change. Awesome. Let's go to the next concept now. Let's go to the next concept. Okay. Some basic things about angles which you should know. If you have a line and it is cutting through two parallel lines, if you have a line and it is cutting through two parallel lines, you should know which angles are equal, which angles are not equal, etc. So first of all, you should know this idea of something called as complementary angles versus supplementary angles. So when I say complementary angles, complementary complementary angles, basically the sum of them, theta 1 plus theta 2, should be 90 degrees. Like 30 degrees plus 60 degrees is 90 degrees. So they are complement. Complement of 30 is 60. Complement of 60 is 30. Similarly, complementary angle of 20 degrees is nothing but 70 degrees. Is nothing but 70 degrees. That's what. Okay. I hope you get what is the meaning of complementary angles. So that is one thing. The next thing that you should know is supplementary angles. Supplementary, supplementary angles, supplementary angles, meaning the sum of them is 180 degrees. The sum of them is 180 degrees. Like 120 degrees plus 60 degrees is nothing but 180 degrees. Is nothing but 180 degrees. Correct? Similarly, if I put 90 degrees, the supplementary of 90 is 90 only, because 90 plus 90 is 180. Okay, so these are supplementary angles. So when you have two parallel lines, these two lines are basically parallel lines. These are basically parallel lines. What happens is, number one, you should know uh, this angle and this angle, they are always equal. Let me just create a duplicate of this. Okay, this angle, oops, this angle and this angle are always equal. Keep this in mind, very, very important. Even you can say this angle is equal to this angle. Same way you can also say this particular angle is equal to this particular angle. Same way you can also say this particular angle is also equal to this particular angle. Okay, so these angles which are on the same side of the parallel lines, upside along that intercept, they are always equal. This is below, this is also below, this is on the left top, this is also on the left top. These angles are equal. That is something which you should always know. Very important geometrical property. Next important thing is this one, supplementary angles, meaning if this angle, if I mark it as theta 1, then this angle will be theta 2, meaning their sum will be 180 degrees. Their sum will be 180 degrees. All the angles on the interior part, on that interior part, will be supplement of each other. So if this is 20, this will be 170. If this is 60, this will be 120. Like that. Okay, so they are supplementary of each other. Even you can say even this particular angle for that matter. Okay, even this particular angle for that matter. Let's say this angle and even this angle, they are also supplementary of each other. So if this is theta 1, this will be nothing but theta 2. So they are supplementary angles. So that's why I put it in the same shade, theta 1 plus theta 2. Is this clear, my dear students? Is this clear, my dear students? Perfect. Okay, very nice. Awesomeness. You should also know one last thing. Opposite angles are always equal, meaning something like this. This angle will always be equal to this angle. Even this angle and this angle are equal, so even this will be equal. This angle will always be opposite to it and equal. This and this are also opposite and they will be also equal. So opposite angles are equal. So this is opposite. Opposite angles are equal. Opposite angles are equal. Okay. So here the interior angles are supplementary. The interior angles of parallel lines are supplementary angles. These are basically your nothing but alternate angles. These are alternate angles are basically equal. Okay, these are basic things which you should know about angles till this point. Everybody clear about this, my dear students? Why not 90? That is, there is a proof soul of Indian mythology why it works. It is not 90. You can also think that this dot plus this one will be totally 180. This will be totally 180. So it so happens that if you take a dot and this one, the total angle will be 180. So this dot plus this one will also be 180 degrees. So this one plus this one will be 180 degrees. Okay, fair enough till this point. Okay, very nice. Next important thing which you should know, next important thing which you should know is about the triangles properties, like basic things which you should know, basic things which you should know about triangle. So triangle properties, triangle properties. One of them is this angle, this angle, and this angle. If I mark it as alpha, beta, and gamma, alpha, beta, and gamma, then all the sum of the angles alpha plus beta plus gamma is nothing but 180 degrees. Very standard thing. Very standard thing. Also, if this side is A, this side is B, and this side is C, if this side is A, B, and C, okay, and let's say I can draw a perpendicular or the height of the triangle. If I can draw the height of the triangle, okay, if I can draw the height of the triangle, let's say this is the height of the triangle, then the area, of the triangle is nothing but half into the base multiplied by the height, base, and into half. That will give me the area of the triangle. You will also see, a very important relationship which will hold true, and regarding sine, cos, tan, etc., which are the trigonometric ratios. So let me just put that before showing you the actual thing. When you have a beautiful right angled triangle, when you have a nice right angled triangle, and let's say I call this as the base, this as the height, and this as the hypotenuse, right? And we know hypotenuse, square is the base square plus your height square, which is your Pythagoras theorem, which is nothing but your Pythagoras theorem. We also can define basic trigonometric ratios, like for example, if this is theta, then sine theta is always opposite side, which is height, divided by the hypotenuse, Similarly, cos of theta will always be adjacent to that angle, which is in this case the base, divided by the hypotenuse. And tan theta is a trigonometric ratio which is always opposite by adjacent. So it is nothing but in this case, it is nothing but the height divided by the base. The reverse or the inverse of these trigonometric ratios also you should know, which is nothing but cosec theta, Sine theta's opposite is cosec theta. So that is hypotenuse divided by height, which is basically 1 by sine theta, which is nothing but 1 by sine theta. Similarly, you can also have sec theta. Which is nothing but hypotenuse, divided by the base, which is also 1 by cos theta. Lastly, you have cot theta, which is exactly opposite of it. It is adjacent by opposite. So the opposite over here is the height. So it is also 1 by tan of theta. These are some standard trigonometric ratios which you should definitely remember and know. Okay. Now that you know these trigonometric ratios, I think I have just revised this. You should know this particular formula in a triangle which says opposite side by the sine of the angle, the ratio is constant. This is called also as the sine rule. This is also called as the sine rule of a triangle. Opposite side, if it is A, the angle is alpha, so the sine of alpha. Opposite side upon the angle, sine, so sine B upon sine beta. Side upon the angle opposite it, which is C upon sine gamma. This ratio always holds true. This is also called as sine rule. You might have also seen it in different vectors chapter booklets or coaching modules as well. Okay, you might have also seen it in some coaching booklets as well in a different way in terms of equilibrium of forces and all of that. So this is a very, very important rule which you must remember, okay, which is called as sine rule for a triangle. Interior angles is sum 180, area of the triangle half base into height. Very, very straightforward. Till this point, everything is clear. Till this point, everything is clear. Very good. You can also remember one additional property which is also called as the cos rule or cosine rule. Cosine rule. Very rarely you might need it, but I'm just giving it for the sake of giving it, which is nothing but if you take any side, let's say for example A, you square it, that will be equal to the sum of the squares of the other two sides, meaning B square plus C square minus 2 times the product of the sides, the remaining sides, B into C, into cos of the angle opposite that A, which is basically cos of alpha. This is cosine. Again, very rarely used, but I'm giving it for you. Similarly, you can say if I put B square, what will it be? Take the remaining two sides. What are the remaining two sides? A square and then B square. Put minus sign. Then take the 2 times product of these two sides. So it will be 2 times of AB. Which angle is opposite B? Beta. So it will be minus cos beta. That's all. Okay. Minus cos beta. Everyone with me on this? Everyone with me on, oh sorry, why did I put, sorry. What did I just do? I had taken B and C, sorry. If I've taken B square, then it will be A square and C square. A square and C square minus 2 times of AC, 2 times of AC, cos of basically beta over here. Similarly, if I take C square, what will I do? The remaining two sides are A and B. So A square plus B square minus 2 times of AB. Which side is opposite C? Gamma. Sorry, which angle is opposite C? It is gamma. So minus cos of gamma. That is why it is called cosine rule, because cos is there. This is called sine rule because sine is there. So these two rules also helps you in so many problems. Yes, Hero Brian, you would have seen this as Lamy's theorem, correct? You would have seen this as Lamy's theorem, but in mathematics, it is actually sine rule. Simply put, okay, it is actually sine rule. Remember all these things, very, very crucial. Another important thing regarding a right angle triangle, which I would like to tell you over here. Observe this. You should know this very important property. If I happen to drop a perpendicular, let's say that perpendicular is P, then it will divide the hypotenuse into two parts, one part here and maybe one part over here, Let's say this part is, let's say, B, and let's say that part is, let's say, A. This is a right angled triangle. Please bear that in mind. Then what happens is, if you take that perpendicular distance and square it, it is always the product of the two parts in which it divides the hypotenuse. So it will be A into basically B. So you had divided the hypotenuse into two parts by dropping a perpendicular. that perpendicular square is always this part into this part, something every student should be aware of. Next important property which you should know of a right angle triangle, I think this is very, very straightforward, is if this is obviously 90 degrees, then this angle and this angle are always going to be complementary angles. Theta 1 and theta 2 are always going to be complementary, meaning their sum will be how much? 90 degree. Always their sum will be how much? 90 degree. Very important property, my dear students. Okay, I have told you what complementary angle is right over here. Basically, their sum is 90 degree. Okay, so if this is 30, this is 60. If this is 10, this is 80. Okay, that's how it works. Always the interior angles of a right angle triangle are always complement of each other. Okay, very nice. So we learned this also. We learned this also. Also, you should know in a triangle what are the different things called. What are the different things called, different important points when you draw different lines from one point, one vertex to the other side. See, when you take the midpoint of every side, when you take the midpoint of every side and join a line from the opposite vertex and join a line from the opposite vertex, these are midpoints of the basically sides, midpoints of basically the sides. These lines, what are these lines called? These lines are basically called as the medians. What are they called? Medians. And the point where they meet, the point where they meet is basically called as the centroid. What is it called? Centroid. Keep this in mind. Okay, very, very important thing which you should know. Very, very important point which you should know. Centroid will come in center of mass and so many other chapters. That is why I'm telling you about this. So it so happens that if you have, let's say any random triangle and you have shown a median. Okay, this is basically a median which I have drawn. And then there is a point which is basically the centroid, which is a centroid, just like I have marked over here. This centroid divides, this centroid will the divide the particular median in which ratio? 2:1. Will divide the median in the ratio 2:1. Usually the symbol for centroid, the symbol used is G. Usually the symbol used for centroid is G. It will always, so the centroid G divides the median, divides the median in the ratio, of 2:1. Keep this in mind. Very, very important. So if this is two parts, this is one part. If this is one part, this is two parts. So 2:1. 2:1. That is the ratio in which it divides it. In fact, this is used in many electrostatics gravity problems, to find the length of something or to find the distance from one point to the other and so on and so forth. So keep this in mind. Very, very crucial. Very, very crucial. Okay, so centroid will divide the median in the ratio of 2:1. Keep this in mind. Similarly, there are other points, but not so important, but just for the sake of telling you, I'll just put it over here so that it is there in your head. If you drop perpendicular bisectors, if you drop perpendicular bisectors, okay, they might pass through the, okay, these are basically perpendicular bisectors. Okay, that is a completely different point. Similarly, you also have angle bisectors which can be drawn. Angle bisectors, meaning this angle you divide it equally, bisect it. This is an angle bisector. There is an angle bisector. Angle bisector, that is completely different. This point over here, This point over here is called as an in-center. This is called as an in-center. And over here, this particular point that you see, this particular point that you see is, you know, your ortho is basically, sorry, why did I put this? Not the not the perpendicular bisector part, just the perpendicular. Sorry, my bad. If I just drop altitudes, if I just drop altitudes like this, altitudes, not the perpendicular bisector. If I just drop altitudes, then this particular point that you see, that is called as your ortho center. Ortho center. Ortho center. These are some basic things which you should know. These are some basic things which you should know. The intersection point of altitudes is orthocenter. The intersection point of angle bisectors is called incenter, and all of that. So these are basically your angle bisectors. Angle bisectors. Angle bisectors. Here, this one is nothing but altitudes. Altitudes. Very, very important property. Okay. Now that you have learned it till here, okay, so let's proceed ahead. Let's proceed ahead. This is done. This is done. Okay. If you take a circle, if you take a circle and this is the radius, then the circumference, like we all know, the circumference is 2 pi into r, and the area of the circle is nothing but pi into r square. Standard things which we know about a circle. Also, what you should know is that if I draw the diameter of the circle, so this is nothing but a diameter of the circle, then the diameter will always subtend 90-degree angle on the circumference. So you take any random point on the circumference, doesn't matter, it will always subtend 90-degree angle. It will always make 90-degree angle on the circumference. So diameter will always subtend, 90 degrees, on the circumference, of the circle. Okay, very, very important. Another important property which you should know of a circle is that if let's say a part of the circle, if let's say there is a part of the circle, that part of the circle, at the center, is subtending some angle. At the center, it is subtending some angle. Let's say it is how much? Theta. Let's say it is some theta or something. Then that same part of the circle will be subtending some different angle on the circumference. How much is this angle versus this angle? If this is theta by 2, or if this is theta, then the angle at the center is 2 times of theta. A very, very important property which you should know. The same part at the center, if it subtends some angle, on the circumference, it will give how much angle? Theta. Okay? Very, very important. Thank you, Kenny. Very good, Mr. Gopal, Savita. I hope you are learning and revising a lot, because very few lectures will cover these things in detail. They directly start off with trigonometry without giving you all these properties, and somewhere or the other in your problems, you would have seen that these things are being used here and there, and then you wonder, where did these things exactly come from? So that is why I'm giving you all these important notes for all of you. Okay. Good evening. Good evening, Naziha. All right. Next important thing, next important thing, if you take a circle and let's say this is the radius, you can draw a tangent to it. You can draw a tangent to it. This is basically your tangent. This is basically your tangent. This is your radius, which is obviously perpendicular to the tangent. If by chance somebody decides to rotate the radius by some angle, rotate the radius by certain angle, let's say the angle by which you rotate is itself given to be theta, then even the tangent at that point will rotate by certain angle. So if somebody draws the tangent, 1 second, little difficult, still I will try. Somebody draws the tangent at that particular point, then you will see even the tangent would have rotated by the same angle theta. A very, very important property. So if the radius tilts by theta, even the tangent would have tilted by the same angle of theta. Useful in many problems where some sphere is there or something else is there, all those things. Okay. Again, a very, very important property. Very, very important property. In fact, that also reminds me of one more important property of triangles. Maybe I can just put it over here, maybe. And that is, if you have an isosceles triangle, this is nothing but an isosceles triangle, meaning these two sides are equal, then you will see even the base angles are equal. These base angles, the base angles are equal. That is one very important property. Not just that, if somebody decides to drop an altitude, if somebody decides to drop an altitude from the vertex, that is from here to here, then altitude means it is perpendicular. Then it is found that the altitude also ends up bisecting the base, meaning this and this are equal. So very, very important. The altitude on the base bisects it, bisects it, bisects it, implies it is also a median. It is also it is also a median. Median means a line which goes from a vertex to the opposite side's midpoint. So this also becomes the midpoint of the base side. Again, a very, very crucial and a important property. Is that clear? Everyone with me? Yeah. Yes, we'll be posting the notes also in the Telegram. Definitely. Very nice. So we did this also, tangent, and this thing is also done. Diameter property also done. And this is also done. Area, circumference, this is also done. Now, this leads to a very, very important trick which you will use in Newton's laws and other chapters, where you will see that you have a horizontal line, where you have, let's say, a horizontal, you have a horizontal like the ground, and then you have a vertical, and then you have a vertical, let's say this is a vertical, and then maybe an inclined plane, then maybe an inclined plane, inclined plane. This is your inclined plane, like this, inclined plane, and perpendicular to the inclined plane, and a perpendicular to the inclined plane. This is your perpendicular. Just imagine this. So I'll repeat again, what are these things? This is your horizontal. This is your horizontal. Then this is your vertical. This is your vertical. This orange one is your inclined plane. This is your inclined plane. And this yellow line is basically perpendicular to the incline. Perpendicular to the incline. Generally, what is given to you is the angle of inclination, meaning this particular angle. So usually you are given this particular angle, which is theta, the angle of inclination of the plane. What you do in all these problems is make these 8 parts by drawing these 4 lines. What will you do? Make 8 parts by drawing these 4 lines. Which are the 4 lines? Horizontal, vertical, inclined, perpendicular to the incline. So you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 parts have been made. What you should do now is, if this is theta, forget one angle after it to the next one, the alternate. This particular angle will be theta. Leave this, go to the next one. This will be theta. Leave this will be basically theta. And so on and so forth. So every alternate, not the consecutive, alternate is going to be theta. In fact, this particular angle is going to be 90 minus theta, which is complementary angle. This is going to be the complementary angle, which is 90 minus theta. Even this one, it is also used in ray optics, in ray diagram, ray of incidence, ray of refraction, all these geometrical parts, wherever you see it, you might have used this some way or the other. This is 90 minus theta. Okay, so again, a very important trick for marking the angles, okay, especially Newton's laws, ray optics, and so many other places where some inclination is there or some angle is involved, and you have to mark the other angles. Okay, this is a very important trick which I have told you. Great. Now that we have learned till here, let's go to some more properties of a circle. Let's go to some more properties of a circle. So if this is our circle, and let's say we take this as the arc, this is the arc of a circle. This is called as the arc of the circle. Then if you draw a line which goes from one end of the arc to the other end of the arc, that is called as, what is it called, my dear students? That is called as the chord of the circle. That is called as the chord of the circle, correct? And little bit crazy to draw, but still I will try. This part is called, from the center you join till the arc, that area which is there, that part, that slice which is there, that is called as the sector of the circle. What is it called? Sector of the circle. Till this point, everybody clear? Arc, chord, and sector. What is chord? Chord is this one. Chord is basically this particular thing from here to this is your. Okay. Now, what is very important is, let's say, for example, I tell you, listen, this is the angle subtended at the center, which is theta. Theta is basically the subtended angle subtended by the arc. Angle subtended by the arc. Then, first important thing, length of the arc formula, my dear warriors, length of the arc will be very important. What is the length of the arc formula? Simply put, it is a radius of the circle. It is just the radius of the circle, into theta if it is in radians. Theta if it is in radians, but if it is not in radians, no issues. Convert it into radians simply if it is in degrees. So if it is in degrees, divide it by 180 and then multiply it by pi. So r into theta in degrees divided by 180 into pi. That is if it is in degrees. If it is in radians, it is simply r theta. r theta. That's it. You don't have to do anything. You don't have to do anything. Okay, multiplication. That's the advantage of writing it in radians. Another important thing is if by chance this theta is very small, if this theta is very small, then only this condition holds true. What I'm going to write next, the length of the arc length which is there. Think about it. If the angle is very, very small, the arc and the chord will be the same. Think about it. The chord and that arc, the length of it will be almost the same. So the length of the arc is approximately equal to the length of the chord. Very, very important again. Very, very important again. Is that clear, everyone? Understood? Pakka? Right, everyone? Great, great. Very nice. Similarly, you might also have, oops. Hmm. Similarly, you might also get a question on what is the area of the sector? Area of the sector. Think about it. The sector is part of the circle. It's like a pizza and it has 4 slices, 5 slices, 6 slices. So the total area has been divided into some parts. So think about it. If the total area of the circle, if the total area of the circle is known to me, if I multiplied by, the fraction, multiplied by the fraction of the entire circle which the sector is making, maybe it is 1/5, 1/6, 1/7, 1/8. That's it. I will get the area of the sector. Everybody getting it? I'll repeat again. If I know the total area is 100 and I know the sector is 1/5 of the entire circle, so it will be 1/5 of 100. So 1/5 of 100, which is 20 units. So what is the area of the circle, my dear warriors? The area of the circle is pi r square. What is the fraction? Theta by 360. Theta by 360. If it is in degrees, if it is in radian, then it is theta by pi. Theta by pi if it is in radian. How much part it is of the entire circle? Fraction, angle which it is giving upon the total angle, which is basically 2 pi actually. 360 degrees is 2 pi. Why is it theta by 2 pi? I'll give you a brief explanation. Think about it. Think about it. Imagine this particular angle is 90 degree, which is nothing but pi by 2 radian. How much part is it? What is the fraction of the entire circle? What is the fraction of the entire circle? Think about it, my dear warriors. It is 1/4, and we can do this. Pi by 2 divided by the total angle of a circle is 2 pi radians, because it is 360 degrees. 360 degrees is 2 pi because pi is 180, 2 pi will be 360. So it will be basically 1/4. It will be basically 1/4 of the entire circle. So the fraction is always that theta divided by 2 pi in radians, which is basically 360 degrees. Which is basically 360 degrees. So hence we wrote theta by 2 pi over here. In fact, pi cancels, and what will I get? What will I get? The area of that thing is nothing but theta into basically r square, theta into r square divided by 2. Theta into r square divided by 2. Everyone with me? Thank you, Sanjana, so much. Clear? Understood? Pakka? Okay. So this is the area of the sector formula. Area of the sector formula. Okay. Many people are going to skip all these things, but I'm doing it for all of you. Thank you, Shruti. Thank you so much. Very good for Brian. Very good, Pavitra. Awesome, Usha Shri. Awesome. Very good. Clear. Okay. So we have learned many properties of tangent, circle, triangle, diameter, this triangle, other triangle, and all of this. Now let's go to the main trigonometry part also. Let's go to the main trigonometry part. And I will tell you that there is a simple table which you can also remember. Let me just put it up for all of you. So, okay. So I'm going to put sine, then I will put cos, and then I will put tan. That is enough because if I know the sine, cos, and tan, I can find sec, cosec, and cot by taking the reciprocal of it. I don't have to worry about it. The major angles which you are going to remember is 0 degrees, 30 degrees, 37 degrees, 45 degrees, 53 degrees, 60 degrees, 90 degrees, 180 degrees. 360 degrees is same as 0 degree because if you start with 0 and go one round, which is 360 degrees, you are coming back to 0 only. So 0 and 360 is the same thing. After that, it just keeps on repeating itself. So let's see. So let's see what are the values of each one of them. Okay, maybe you can also make this table for your revision. Don't just look at this. You have to copy it down in your books, write it again and again so that it enters your head, and randomly think of any value. Sine of 90, okay, cos of 53, tan of 30. Okay, so randomly when you do this, it becomes very convenient for you in exam, or else you will waste a lot of time. So, my dear students, sine of 0, 0. Cos of 0, 1. Tan is sine by cos. So, 0 by 1 is 0. Always to find tan, it is just sine divided by cos. Remember that. Okay, so if you want, I can also put it over here where I mentioned it. Right. Yeah. So, tan theta is also, remember, it is also sine theta divided by cos theta. So divide this by this, hypotenuse cancels, it is height by base, right? That is how it is. Great. So moving on to the next angle which we have, sine 30 is basically half, cos 30 is root 3 by 2. So if you divide this by this, you will just get 1 by root 3. We'll come to 37 in a bit. Sine 45 is 1 by root 2. Cos 45 is also the same. So if I divide this, I will get it as 1. Sine 60 is nothing but root 3 by 2. Cos 60 is nothing but half. Tan 60 is nothing but root 3 divided by 1, which is root 3. Sine of 90, exactly opposite. Sine 0 was 0, so sine 90 will be 1. Cos 0 was 1, so cos 90 will be 0. So 0, 1, 1, 0, exactly opposite. So tan is not defined. Don't put infinity. That is wrong. A lot of people put infinity over there. It is not defined because you cannot divide a number with 0. Okay. Sanjay, I will be doing 1D motion in a separate lecture, definitely. So the graphs of 1D motion, velocity, position, acceleration, I'll be doing it separately in that particular chapter of 1D motion. I've kept, a dedicated video for that only. Don't worry. Okay, because 1D motion is also a very big chapter. There is uniform motion, which is kinematics, and non-uniform motion, which involves derivatives and integration. So when we do derivatives and integration, then when we do slopes and graphs, it becomes very easy. So I will do it with that derivatives and integration. Yeah. Now, for 180, 180, sine 180 is 0. Cos 180 is basically negative 1. So tan 180, 0 by this is just going to be 0. It's just going to be a big fat 0. Now you'll be wondering, sir, what about 37 and 53? So I am going to tell you once and for all a very simple trick And this is a magic triangle, which I will tell you. There is a very beautiful magic triangle. And that magic triangle is a Pythagorean triplet of 3, 4, and 5. Pythagorean triplet are those numbers, whole numbers, which follow the Pythagoras theorem. 3 square plus 4 square is 5 square. 6 square plus 8 square is nothing but 10 square. 12 square plus 5 square is nothing but 13 square. So all these are basically Pythagorean triplets. Clear? Okay. But this Pythagorean triplet only will give that magic triangle. Do you see the number 5, 3, 53? Do you see the number 5, 3, 53? That's it. So this will become 53 degrees. 5 and 3 in between them. 53. How much will this be? Remember, complementary. Interior angles of a right angle are complementary. So this is just 37 degree. This is how much? 37 degree. As simple as that. Now you can get any simple ratio, guys. Very, very straightforward. Say, for example, sine of 37. Sine of 37, opposite by hypotenuse, 3 by 5. 3 by 5. Just put 3 by 5 if you know the triangle. Cos of 37. Cos 37 is adjacent by hypotenuse, so 4 by 5. So this will be nothing but 4 by 5. Tan 37, opposite by adjacent, so it will be 3 by 4. So hence this will be 3 by 4. Let's go to sine 53. 53 sine, opposite by hypotenuse, so it will be 4 by 5. So this will be 4 divided by 5. Then over here, cos 53, adjacent by hypotenuse, so it will be 3 by 5. So this will be basically 3 by 5. And lastly, tan 53, opposite by adjacent, which is basically 4 divided by 3. Understood, my dear students? Yes, Sanjana, the magic triangle. So now these are the basic values of all the standard angles which you must remember, including magic triangle. 5, 3, 53. Don't mark this as 53. This is 5, 4. Then you will be like, sir, is this 54 degree? No, that is a trick to remember that it is 53. It's just coincidence. Don't say, sir, this is then 45 degree. Sir, this is 34 degree. One tight slap you will get then. Okay? Be careful. All right, let's move ahead. Let's move ahead. So this much part is done. This much part is done. We've learned all the standard angles. Now comes the next part. Where what if the angles are not standard? Number one. Number two, is there any rule or property by which I can transform from one angle to the other angle? So let's learn all those transformation, addition, subtraction, and how to find the non-standard angles also. Let's try that out. So starting off with one of the very first thing, and that is called as the small angle approximation. That is called as the small angle approximation formula. Small angle approximation formula. What do I mean by small angles? Small angles are anywhere between 0 to, let's say, maximum 30 degrees. You might say, sir, 30 is huge, but I know 30 degrees is huge. If you convert it into radian, then it is not huge. Actually, 0 to 30 degrees in radian will become 0 radians. Convert 30 degrees into radians, guys. Convert 30 degrees into radians. Come on. Convert 30 degrees into radians. I want to see how many of you can find out the value quickly. 30 degrees into radians. It is pi by 6. So it is basically 3.142 divided by 6. Roughly how much will it be? Roughly how much will it be? Pi by 6 means 0.52 radians roughly. 0.52 radians roughly. Yep. Yeah. So it is basically from this to 0.52 radian. 0.52 is a small decimal number. Small decimal number, you can use it. Perfect. Somebody was saying, what is a magic triangle? Always draw, to find the sine, cos, tan of 37 or 53, draw a right angle triangle. The side which is 3 and 5, the angle inside is 53. 5 and 3. The remaining angle, 90 minus 53 is 37. After this, you can find any cos, tan, sine formula. For example, sine 37. 3 by 4. Sorry, tan 37. Yeah, opposite by adjacent. So 3 by 4. Cos 53. Adjacent by hypotenuse. 3 by 5. That's what the magic triangle is. Is that okay? What was that? Indian mythology. Clear? Okay. Now, this is the range where you can use this approximation, and the approximation goes as follows. Observe it very carefully. Sine theta is approximately the same value as tan theta, which is approximately the same value as theta in radians. This is a very, very important property. And the second important property is the cos of theta is almost equal to 1. The cos of theta is almost equal to 1. To go little bit more extra, you might also put minus theta square by 2, but this theta is so small, and then dividing it by 2 and squaring that will make it even smaller. Imagine if you do 0.5 square, it will become 0.25 square. 0.5 becomes 0.25, and then divided by 2, it will become like 0.12 and something like that. So even then it will become a very small number. So approximately we can tell it is 1. Approximately we can tell it is 1. Is that okay? Assuming the thetas, very, very important, very, very important here. The theta is in radian only, in radians only. Very, very important. Lot of people miss this particular aspect while solving the problems. This is useful in many, many problems, and I'll show you how. Let's say, for example, I want to find the sine of the sine of 0.28 radian. What do you think the answer will be approximately? What do you think the answer will be approximately? If the angle is in the radian, the answer is sine theta is almost theta. So hence the answer is 0.28. You don't even have to worry about. You don't even have to worry about it. Very nice. Then let's take another example. Tan of 0.0021 radian. How much do you think approximately it will be? Well, tan of a very small angle is the angle itself. So hence, it is still going to be 0.0021. Similarly, if I ask you what is cos of 0.016 radian, since 0.016 is a very, very small angle, I can use the small angle approximation formula. Cos of a small angle is that number 1 if theta is very, very small in this particular range. Yes, so I can say it is approximately 1. Is this absolutely clear? All these angles were in radians. Sine and tan, it will be the angle. Cos, it will be 1. Okay. Now, let's go a step further, and let's say it is not in radian. Let's say it is in degrees. Sine of 10 degrees. I think 10 degrees is small only. It is between 0 degrees to 30 degrees. Or if it is in radians, it is 0 to 0.52 radians. Perfectly. No issues. But I can't write 10 degrees, I have to first convert it into radians. First convert it into radians. So 10 degrees, if I want to convert it into radians, divide degrees with degrees. So 180 degrees and multiply by pi. So 10 and this 0 cancels, it will become pi divided by 18. So hence, this will be sine of pi by 18 radian. Pi by 18 is a small number, hence the final answer will be pi by 18. Hence the final answer will be pi by 18. As simple as that. Got it? Understood? Now pi value you can substitute, and 3.14 divided by 18, whatever value you get in decimal, that is the final answer. Similarly, if I tell you, come on my dear warriors, find the value of tan of 2 degrees. What will you do? First things first, convert degrees into radians. So this is 2 degrees converted into radians. So 2 degrees divided by 180 degrees multiplied by 100 and, sorry, multiplied by pi. This will become 90. This will just become 90. So this will become tan of pi by 90 radian. When it is in radian, only then I can use the formula. Hence it is pi divided by 90. Hence it is pi divided by 90. That's how you find the small angles sine and cos and tan and whatever. Okay, clear? Till this point, everybody understanding it? We have seen the standard angles, magic triangle, okay? And we have also seen the small angle approximation formulas. Very good, very good. I hope you are getting a lot of confidence by watching the video till this point. And if you have forgotten to smash the like button, quick reminder, smash it right now. And if you have forgotten to subscribe, subscribe, because this is how I teach very slowly from the basics so that everybody understands, covering all the things application point of view without, making you struggle, learn through the derivations, rather help you in the NEET exam. Okay, because in the NEET exam, it's an application oriented exam, meaning questions are framed based on the formula or the concept which you have to apply, right? Very good. Pakka, very good. Savita, pretty awesome. Usha, awesome, awesome, awesome. Very nice. Let's move. Let's move to the next one. Let's move to the next one. Now, what if the angles are not standard? What if you have to find some 120 degrees and all of that? So we'll see the formulas for that. So some basic trigonometric identities. Trigonometric trigonometric identities. First one, everybody would know this: sine square theta plus cos square theta is equal to 1. Everybody knows this, yes or no? Come on. You might remember it from your school days. What are the other trigonometric identities? What are the other trigonometric identities? Come on, my dear warriors. Sine square theta plus cos square theta is 1. Something related to tan also? Something related to tan also? Yes. What was it? 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is nothing but sec square theta. You also have one more thing. Instead of tan, you make it cot. So 1 plus cot square theta is nothing but, instead of sec, this will become cosec square theta. A very, very important formula. Okay? Everybody should know this. Everybody should know this. Okay? Sine square plus cos square is 1. 1 plus tan square is sec square. 1 plus cot square is cosec square. All these are standard formulas. Next important thing which you should know. Sine of minus theta is basically minus sine theta. So if you find sine of minus 30 degree, it is minus half, because sine, look at this. If I want to find sine of minus 30 degrees, what will I do? I'll put it as minus sine 30. Sine 30 is half, so answer is minus half. Very, very important identity. Similarly, cos of minus theta is not minus cos theta, it is just cos theta. So if I have to find cos of minus 30, it is just the same as cos 30. Cos 30 is nothing but root 3 by 2. So that is the answer. Okay, so that is for cos. There is no minus sign which will go out. For tan of minus theta, tan of minus theta is minus tan theta. So for example, tan of minus 45 degree, it is minus tan 45. What is tan of 45? It is 1. So the answer for this is negative 1. The answer for this is negative 1. So that's what it means. Okay. So whenever the angles are negative, use these relationships. It will help you a lot. Use these relationships. It will definitely help you a lot. Very good. Now moving on to the next one. Addition, subtraction formulas. Addition, subtraction formulas, again very, very important, which goes like this: sine of alpha, or sine of A plus B is, whenever it is sine, the sign SIGN, positive, negative, that sign is the same. So if it is plus, put a plus over here, and what will happen? The terms are different. The sign SIG is same, but the term, the ratio is different. Meaning, if it is sine, then you put sine with cos. So sine A cos B, and then once you have used sine A and cos B, use sine cos A sine B, cos A, and then sine of B. This is what happens. Similarly, if you put sine of A minus B, because there is a negative sign, for sine, the signs should be same. So instead of plus, put a minus, but the terms are different. So it will be sine cos, cos sine. So sine with cos, cos with sine, the terms are different. Sine A cos B, cos A sine B. That is how it goes. Is that clear, my dear students? Is that clear, my dear students? Perfecto. Awesome. So now the next two. Cos of A plus B. Cos of A plus B, and then cos of A minus B. So these are addition and these two are subtraction. Because in sine, the sign is same. In cos, the sign is not same. So if it is positive, it is negative. If it is negative, it is positive. And the terms are similar. Meaning, it is cos, sine. Terms are same. Sign is opposite. Cos, sine. Cos, sine. Exactly. And what you will see is it will be cos A, cos B, sine A, sine B. Cos A, cos B plus sine A, sine B. This is the formula. Addition and subtraction. Addition and subtraction. For example, for the sake of example, let's take few examples now so that you get a hang of it. Imagine we had to find sine of, imagine we had to find the sine of, let's say, 120 degrees. What I will do is, I'll think, sine of 120, can I write it as something plus something? Yes, I can write it as, I can definitely write it as sine of 90 degrees plus 30 degrees. Oh, so now I can use sine of A plus B formula. Sine of A plus B formula. Perfect. So what will I write? Because it is sine, SIGN will be same. So plus means plus will come, but the terms will be different. So sine, cos, sine. That's how it works. So sine 90, cos 30, cos 90, sine 30. Cos 90, sine 30. As simple as that. So what is sine 90? 1. What is cos 30? Root 3 by 2. Root 3 by 2. Right? Plus cos 90, 0. Sine 30, half. 0 into anything is 0. Hence the answer is root 3 by 2. Hence the answer is root 3 by 2. Everybody clear till this point? Everybody clear till this point? Very good. Excellent day. Very nice. Very nice. Keep it up. Keep it up. Keep it up. Let's say we have to find, the cos of 15 degrees. Cos of 15 degrees using addition subtraction rule. Let's think, can I get 15 degrees using something? Definitely we can. I can write it as cos of 60 degrees minus 45 degrees. 60 minus 45 is 15. So that's how I can get 15 degrees. This is cos A minus B. For cos, the sign is opposite. So minus will then become plus, and the terms are same, meaning cos, sine. Cos, sine. So cos 60, cos 45, sine 60, sine 45. So cos 60 is nothing but half. Cos 45 is nothing but 1 by root 2. Cos 60, 1 by 2. Cos 45, 1 by root 2. Plus sine 60, root 3 by 2, and sine 45 1 by root 2. So 2 root 2 is common. 2 root 2 is common. Root 3 plus 1 is there on the top. So root 3 plus 1 is there on the top. Everyone with me? Everyone with me? Very good, very good, very good. Awesomeness. There was one more thing which I think I missed, and that was the tan formula. I just recollected it. Maybe I can create a duplicate and put the tan formula over here. Let me put tan also, guys. Tan was remaining. So let me put tan formula. So tan of A plus B is tan of A plus tan of B. Just go as it is, but divide it with, because there is a plus, put a minus sign, 1 minus. Now take the product, tan A, tan B. That's all. Similarly, tan of A minus B, go with the flow. Tan A minus tan B. Tan A minus tan B. Tan A minus B, tan A minus tan B upon, instead of minus, you put plus, 1 plus the product. Tan A, tan B. That's all. That's how you go about it. Let's try an example so that you guys are confident, super duper about it. Okay, let's find out the tan of 150 degrees. Tan of 150 degrees. Let's do this, my dear students. 150 can be written down as tan of, think about it, tan of 90 plus 60. 90 degrees plus 60 degree. Yes or no? 90 plus 60 degree. Perfect. Very good. Very good. Excellent. So, how about this? Go with the flow. Meaning tan A plus B is tan A plus tan B. Whole thing divided by, if it is plus, put minus, 1 minus tan 90 tan 60. The problem of writing it like this is tan 90, I do not know the answer. Tan 90, I do not know the answer. So solving it this way is not really right. Tan 90 is not even a number, so do not do this. Okay, a lot of people will think about this, and that is why I told you over here, by solving this problem, that you cannot proceed beyond this, because tan 90 is something which I do not know. So don't use this method. Don't use this. Instead think, can I write tan 150 as tan of 180 minus 30? This is more beneficial. 180 is tan, I know. 180 is tan, where did it go? 180 is tan is 0. 180 is tan is basically 0. So let's go over here. What do I get? Go with the flow. Tan 180 minus tan of 30, whole thing divided by, if there is minus, put plus, 1 plus product, tan 180 into tan of 30 degrees. So what will it be? Tan 180 is 0. Tan 30 is 1 by root 3. Whole thing divided by 1 plus 1 plus. Tan 180 is 0. Doesn't matter what you multiply it with. Anyways, tan 130 is, tan 30 is 1 by root 3. 0 into anything is 0. So it will be just minus 1 by root 3. Minus 1 by root 3. That is the answer. Is that okay? Understood how these things work? How to use addition, subtraction formulas? Be it sine, cos, tan. Okay? It's simple formula substitution. Simple formula substitution. Okay, very nice. Now, going ahead, you also sometimes might need these double angle formulas. Double angle formulas. What is this double angle formula? Imagine I want to find sine 2 theta, how much it is. Cos 2 theta, how much it is. Okay, usually you will need sine 2 theta and cos 2 theta. Double angle, the double of the angle. Very straightforward. Actually, sine 2 theta can be found using this formula only. Where is it? Instead of a and b, put theta plus theta. Instead of a and b, put theta plus theta. Theta plus theta, 2 theta. So sine theta cos theta plus cos theta sine theta. So sine theta cos theta sine theta. So 2 times sine theta cos theta. So 2 times the sine theta cos theta. So hence the answer for this is 2 sine theta cos theta. You will see this in motion in 2D range formula. Motion in 2 dimensions range formula. What about cos 2 theta? No worries. Go back to this formula. Go back to this formula. Cos theta plus theta. Put A as theta, B also as theta. It will become cos 2 theta. Will become cos theta minus sin theta. Cos will become cos square. Sin will become sin square. It will become cos square theta minus sin square theta. That's it. So that is the answer for that, my dear warriors. So it will be nothing but cos square theta minus sin square theta. But sometimes you might need it in different forms. So I am writing and helping you with those forms as well. What I can also do, this cos square, I write it as 1 minus sine square theta. Imagine. And this sine square is as it is. This sine square is as it is. Sine square and sine square will become 2 sine square. So this can be also written down as 1 minus 2 sine square theta. Another option is instead of writing cos as 1 minus sine square, I can also write sine square theta as 1 minus cos square theta. And this cos square theta is as it is. This cos square theta is as it is. What will you get then? Minus minus will become plus cos square will become 2 cos square theta, and this minus 1 will be there. So all these are equivalent formulas. Cos 2 theta is cos square minus sine square, or 2 cos square minus 1, or 1 minus 2 sine square, or 1 minus 2 sine square. Why these transformations are required is because of the following. Sometimes instead of going from double angle to single angle, you might have to go from single angle to double angle also. So in that case, you will need it. Say for example, I use this. So imagine what will happen. Imagine what will happen. Okay, just look at this. If I take cos 2 theta is equal to 1 minus 2 sine square theta. Therefore, 2 sine square theta is 1 minus cos 2 theta. So therefore, sine square theta is half minus cos 2 theta whole thing divided by 2. This also can be written down. Okay, sometimes you might need this. Sometimes you will need this formula, meaning imagine cos 2 theta is 2 cos square theta minus 1. Bring that 1 on the other side. So 2 cos square theta is equal to 1 plus cos 2 theta. Take that 2 below. So cos square theta will be half plus cos 2 theta divided by that 2 over here. Sometimes you might need these transformations in some problems. Very difficult problems, you might need it. Otherwise, you don't need it. If you know these basics, you can always get to these formulas. It's not that difficult. Don't have to remember it. I'm just telling you, you might need these steps in some problems. I'm not asking you to by heart them. Main thing that you should by heart is these things. Is that okay, everyone? Very good. Very good. Next thing, let's go. Let's go, everyone. The next formulas is sine of A plus sine of B. You will see these kind of formulas are typically used in waves chapter and SHM chapter. And SHM chapter. Okay. So basically this one. Then you also have sine of A minus sine of B. Then you also have sine of A minus sine of B. Then you also have cos of A plus cos of B, and then you have cos of A minus cos of B. So rarely used, but when required, you will need it for sure. You will need it for sure. In all these formulas, the number 2 comes over here. First of all, the number 2 will definitely come over here. This is the most important thing. This is the most important thing. Okay, everyone, till this point? All right, very good, very good. Now, if it is sine A plus sine B, if it is sine A plus sine B, then what happens? Because there is plus, you will get sine of A plus B by 2 over here. Then you will get cos of A minus B by 2 over here. This is what you will get. Sine of A plus sine of B is 2 times sine of A plus B by 2 into cos of A minus B by 2. This is what you're going to get. This is what you're going to get. But if it is minus, then you will get over here cos of A plus B by 2. And here you will get sine of A minus B divided by 2. That's the only difference. This cos will come here, this sign will go here. A plus b by 2, a minus b by 2 will stay intact. Will stay intact. No change over there. No change over there. Very good. Again, for cos a plus cos b, again you will have something like a plus b by 2 and a minus b by 2. Again over here, a plus b by 2 and a minus b by 2. But what comes outside is very important. What comes outside is very important. If it is cos A plus cos B, then it is just cos and cos both times. Cos and cos. For sine, it is sine cos or cos sine. But for cos, it is just purely cosines only when there is addition. When there is addition. But when you subtract, basically subtract, my dear warriors, then you put sine over here. Sine of a plus b by 2 into sine of a minus b by 2. Okay, that's the major change. That's all. Is this clear till this point? Is this clear till this point, my dear warriors? Perfect. All right. Awesome. Okay. Now, these formulas you will rarely use. Main thing is these formulas, double angle formulas. Where did it go? Double angle formulas and all that. Let's do some questions on double angle formulas so that you are used to it. Imagine I want to find, okay, say, let's take some random number like, say, 74. Yes, interesting number. 74 degrees. Now think, how can you get 74? Is there some number which you can add, subtract, multiply and get the 74 degrees using some standard angles? I think you can, because 74 is nothing but 2 times of 37 degrees. Is nothing but 2 times of 37 degrees, and 37 degrees is a standard angle. Oh, perfect. And what is the double angle formula? Sine 2 theta is 2 sine theta cos theta. So that's it. So I will write it as 2 times sine theta cos theta. Perfect. Now what is sine 37 and cos 37? For that I told you the special looking triangle 3, 4, 5, where this is 53 and this is 37. This is basically 37. So sine 37 is 3 by 5. Sine 37 is basically 3 by 5. Cos 37 is 4 by 5. So just put 4 by 5 over here. That's it. Our job is done. Our job is done. So 2 3s are 6, 6 4s are 24 and divided by 25. So the answer is 24 by 25. 24 by 25. Is that absolutely clear, my dear students? Everybody understanding it till this point? Clearo? 100%? Can we go ahead to the next one? Can we go ahead to the next one? Perfecto. Let's do this. Come on, let's do this. How about finding the cos of 120 degrees using the double angle formula. Using the double angle formula, cos 120 is cos of 2 into 60 degrees. Cos of 2 into 60 degrees. What is the double angle formula for cos? Cos square minus sine square, or 2 cos square minus 1, or 1 minus 2 sine square. I think we can go with this. It's going to be very easy. Let's use 2 cos square minus 1. Let's use 2 cos square minus 1. So 2 cos square 60 degrees minus 1. So what is cos 60? It is basically half, but you have to square it. So what will it become? It will become 2 by 4 minus 1, which is 1 by 2 minus 1, which is minus 1 by 2, which is minus 1 by 2. So cos of 120 is negative half. We got it. Cos of 120 is negative half. We got it. Not plus 1 by 2, negative half. Yeah. Clear till this point? Understood? Very nice. Very nice. Let's move ahead. Let's move ahead to the next problem. Okay. Now, most of it is complete trigonometry. One small part is remaining. See, to find 120 or 70, or let's say something else also, whatever, we did over here. Let's say this one, 150, etc. We struggled a bit using this formula. What if I tell you, you can find this out very simply within seconds using a trick. So I will tell you what the trick is. So you don't even have to use this formula. You can avoid using this. Yeah, this can be a backup option, a second option in case you don't remember the trick in the exam. But this is obviously a method. I am going to now teach you a trick to find the sine, cos, tan of any random angle using standard angles by a small trick. By a small trick. Okay, what is the trick? Observe carefully. What is the trick? Observe. See, your complete set of angles can be divided into 4 quadrants. 4 quadrants starting like this. Say, for example, your angle is here. 1 second. Let's say your angle is here. So here the theta, is between, basically theta is between 0 degrees to 90 degrees. Radians wise, it is 0 radian to pi by 2 radians. 0 radians to pi by 2 radians. Till 90, this is the case. Beyond this, if you are here, then you measure this angle, then you measure this angle from here till here. Then our theta is between 90 degrees to 180 degrees. Radians wise, it is pi by 2 radians to pi radians. Is that right? So pi by 2 to pi radians, or 90 to 180 degrees. Remember, this angle is 0 degree. When you come here, it is 90 degree. When you go over here, it becomes 180 degree. When you come here, this will become 270 degree. And when you come back, it will again become 360 degree. 0 degree, or basically 360 degree when you come back, correct? This is how it goes. 0, 90, 180, 270, 360. 360 is like reset. You are coming back to 0. If you look at it radian wise, this is 0 radian. This is pi by 2 radian. This is pi radian, and this is 3 pi by 2 radian, and this is 0 radian, or basically 2 pi radians. Are these markings very, very clear in your head? Do you understand where these have come from? Because pi radians is 180 degree. So 360 degrees 2 pi. This is 3 pi by 2. You can convert 270 into radians very easily. It will be 3 pi by 2. How? This is pi by 2, 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 pi by 2. 3 times. 90, 90, 90. Pi by 2, pi by 2, pi by 2. 270. 3 pi by 2. Okay? Like that also you can visualize. Very nice. If your angle is somewhere, or line is here, then the angle that you will be measuring is this angle. So this is theta. So it will be anywhere between 180 degrees to 270 degrees. Radians wise, pi radians to 3 pi by 2 radians. 3 pi by 2 radians. And when you are over here, it's like going like this. You're measuring that angle. Then it is anywhere between 270 degrees to 360 degrees, or radians wise 3 pi by 2 radians to 2 pi radians. This is what that angle is. Obviously, this is your first quadrant. This is your second quadrant. This one is your third quadrant. And the last one over here is your fourth quadrant. These are your four quadrants and all the angles have been mentioned. So if I tell you 240 degrees, immediately which quadrant will it lie? It will lie in the third quadrant. If I tell you 330 degrees, it will lie in the fourth quadrant. 170 degrees, second quadrant. 17 degrees, it will lie in the first quadrant. 200 degrees, it will lie in the third quadrant. So if I tell you an angle, you can immediately tell me the quadrant where it lies. Correct? Everyone till this point? Okay. Now it so happens that if you are in the first quadrant, any angles sine you measure, cos you measure, or tan you measure, all of them are positive. Basically, all are positive. All are positive. If you go to the next quadrant, which is the second quadrant, which is nothing but the second quadrant, then only sine is positive, rest all are negative. Rest all are negative. So only sine is positive. Only sine is positive. If you go to the third quadrant, sine is negative, cos is also negative, only tan is positive. Only tan is a positive ratio. If you go to the fourth quadrant, sine is negative, cos is positive, tan is back to negative. Now you'll be like, sir, how do I know which one is positive or negative, etc.? Very simple. Remember this phrase. Remember this phrase. When you're going from here to here, basically you are going like this. From first quadrant to second quadrant to the fourth quadrant, you are going like this. Please remember that. Please remember that. So just remember this phrase. All, okay, silver, all silver tea cups. All silver tea cups. If you remember this phrase, it's very, very simple. This S over here, this S over here stands for sine. That T over here stands for tan. And that C over here stands for cos. And all means literally everything. So all silver teacups, these are the positive quantities. What are these? All these things are positive. Rest everything else is negative. You can see that everything is positive. Only sine is positive, rest is negative. Only tangent is positive, rest is negative. Only cos is positive, other things are negative. That is a simple way of remembering it. Yeah, you can also remember add sugar to tea, all silver teacups. It's completely up to you. Okay, fine. It's up to you what phrase you want to remember. But the idea is, please remember who is positive and who is negative. So let's see whether you can solve a simple question as to who is positive versus negative. Let's see, guys. I want everybody to post the answers for question number 1. Sine of 130 degrees, positive or negative? Cos of 200 degrees, positive or negative? Tan of 300 degrees, positive or negative? Fourth question, uh, cos of cos of uh, 280 degrees, sine of 350 degrees, tan of 105 degrees. Come on, whether it is positive or negative, that is what you have to mention in the chat box. First, starting off with 130 degrees. First, starting off with 130 degrees. Come on, my dear warriors. 130 degrees. Where is 130 going to be? It is going to be in the second quadrant. Sign is positive. So hence the answer must be positive. 200 degrees. Where is 200 degrees going to be? 200 degrees is going to be in the third quadrant. Third quadrant cos is negative. So hence the answer for this is negative. Tan 300. Where is 300? 300 will be somewhere here in the fourth quadrant after 270 before 360. In the fourth quadrant, tan is negative. All silver teacups. Only cups C. Cos is positive. So this is also negative. Cos of 280. Come on, my dear warriors. Cos of 280. Where is 280? 280 is here. Here in the fourth quadrant after 270 degrees. It is after 270 degrees. So cos is positive. So hence the answer for this is positive. Sine 350. 350 is again in the fourth quadrant. Fourth quadrant sine is negative. So the answer for this is negative. 105. 105 is over here, somewhere here, second quadrant. Second quadrant, tan is negative. That's it. So the answer for this is negative. Answer for this is negative. Clear? How to find the sign? How to find the sign? This much is clear? Very good. Now the next part. Observe this carefully. Observe this carefully. If you want to measure the sine, cos, tan of anything, sine, cos, tan of anything, okay, then with this vertical or horizontal line, see how much more it is, or how much, see how much more it is from that vertical line or less from that vertical line, or see how much less it is or more it is from that horizontal line. This is the first step. The next step is, the next step is whenever you measure with the vertical line, whenever you measure anything with the vertical line, okay, the angle, just remember this. I will show you the application of it. Initially it is difficult to understand, but later on you'll be like, "Arey sir, it is so simple, such a nice trick this is." Whenever you measure anything with the vertical line, then the sine will become cos, cos will become sine, tan will become cot, and cot will become tan. This is what it is. But whenever you measure anything with the horizontal line, then sine remains as sine, cos remains as cos, tan remains as tan only. So there is no change with the horizontal, always there is change with the vertical. So basically, there is no change over here. And with this, there is always going to be a change. So let's understand what it means, to use this particular trick. Say, for example, I want to find sine of 150 degrees. Sine of 150 degrees. I have two options. I have two options. I can write it as sine of 90 plus 30 degrees, correct? This is one option. The second option that I have, I can also write it as sine of 180 minus 30 degrees. Sorry, this is not 30, this is 60, my bad. 180 minus 30 or 90 minus 60. Either ways, the answer should come out to be the same. Now, observe this, my dear warriors. Here, when I do 90 plus 60, I am measuring with respect to the vertical line. This is 90-degree line. So I am going more 60 degrees from that 90-degree line. Isn't that what it means? When I write it 180 minus 30, what I mean is, this is 180-degree line. This was 90-degree line. From 180, you're going behind. You are basically going behind by 30 degree. What did I tell you? Whenever You're measuring with horizontal, no change. With vertical, there is change. Meaning, in this problem, sine 90 plus 60, sine 90 plus 60, this sine will now become cos because I'm measuring with vertical. Whenever I am measuring with vertical, there is a change. Sine will become cos. Forget this 90, just write it as cos 60. Just write it as cos 60. Understood, my dear students? What did I just do? That extra angle which is there, only put that, forget that 90, 180, etc. But this sign became cos because I am measuring with vertical. If I write it with this perspective, because with horizontal there is no change. There is no change. So the sign will remain sign. Forget that 180 or whatever it is there. Just write it as sine 30. Just write it as sine 30. Now, what is the value of sine 30? It is basically half. What is the value of cos 60? That is also half. Whether you go like this or whether you go like this, answer came out to be the same. So I had two different ways of solving the question. Both the answers came out to be the same. But the point is, I am teaching you how to use that trick using this problem. With vertical, change it. Sine becomes cos, cos becomes sine. With horizontal, no change. Whatever that 90, 180 is there, forget that. Only that extra angles sine or cos you take. But while doing it, be very careful. There is one thing which you might miss in this problem, and that is the sign, SIGN, positive, negative of the identity. See, sine 90 plus 60, which quadrant you are? Second quadrant. All silver teacups, silver, sine. Sine is positive. Luckily, the answer is positive, and actually also it should be positive. Okay. So you need to check that also, or else you will have to change the value over here with positive to negative, negative to positive. Let's do more questions so that you get a hang of it. Let's do more questions so that you get a hang of it. Okay. So let's try this out, my dear students. Cos, cos 120 degrees. Again, we have two ways of going about it. I can write it as cos of 90 plus 30 degrees, or I can write it as cos of 180 minus 60. One and the same thing. First of all, in the second quadrant, what happens to the cos value? Because this angle is in the second quadrant, what happens to this? In the second quadrant, cos is negative. Cos is negative. So no matter where you are, first of all, put a negative sign. First of all, put a negative sign. Without that, don't do anything. Yes. Do you understand why we put the negative sign? Because 120's cos has to be negative. It's in the second quadrant. All silver. Sign only is positive in the second quadrant. Now, when you write 90 plus something, 90 minus something, what did I tell you? With vertical, there is always a change. Okay. So cos will become sine. Only the remaining part. That's it. Sine 30 is half. So the answer is minus half. Even if you go here, you will get the same thing. This is with horizontal. So cos will remain cos. So it will be cos 60. Cos 60 is half. So minus half, one and the same thing. Clear? Let's do more. Let's do more. Okay. Let's try this out. Tan 135 degrees. It's up to you how you want to go about it. I can write it as tan of 90 plus 45. Is that right? 90 plus 45 is 135 degrees. Perfect. And because I'm going with respect to 90 degrees, tan should become cot, cot will become tan. Second thing, this is in the second quadrant. This angle is in the second quadrant and the answer should be negative. So first of all, put a minus sign. And the tan should become cot, cot of 45. Cot 45 is 1 by tan 45. So what is tan 45? It is 1. So the answer is negative. So hence the answer is -1. Cool. Let's do one more question. Tan of tan of 225 degrees. Tan of 225 degrees. First, think about it. 225 degrees is in the third quadrant. Is in the third quadrant, all silver T. Tangent is positive, so answer must be positive. Okay, it's up to you how you want to do it. Let's say I write it as tan of 180 plus 45. Correct? 225 is 180 plus 45. Whenever you measure with respect to horizontal, then there is no change. When there is measurement with respect to horizontal line, no change with respect to the horizontal line. Okay, so there is no change whenever you measure with respect to the horizontal line. The change only occurs whenever you measure with respect to the vertical line. Correct? That is what happens. All right. So let's do that. Answer is positive only. Tan should remain tan. Forget this 120, sorry, 180 and just write it tan 45. Tan 45 is 1, hence the answer is just simply 1. Nothing more, nothing less. Let's go to the next question coming up on your screen. If I want to find sine of 300 degrees, let's see how do we get it. Sine of 300 degrees, okay? Sine 300, I think I can write it 270 plus 30. I can write it as 270 degrees plus 30 degrees. Make sense? 270 plus 30. Now 270 degrees, think about it guys, it is that vertical line. 270 degrees, 270 degrees, 90 degrees is that vertical line. So you are measuring with respect to that vertical line. So it is basically this angle, which is 30 degree. You are measuring it with respect to 270. That is the first thing. Okay. So 100% sine will become cos. Sine will become cos. Next important thing, this angle is in the fourth quadrant. And in the fourth quadrant, the value of sine is negative. So 100% the answer must be negative. Forget the 270, just write 30 degrees. That's it. Cos 30 is root 3 by 2. Hence the answer is minus root 3 by 2. Hence the answer is minus root 3 by 2. Very good. Let's go to the next question on your screen. Cos of cos of 210 degrees. Cos of 210 degrees. It's up to you how you want to do this problem. Let's say we write it as cos of 180 plus 30. 180 plus 30. So simple now because I'm measuring it with respect to 180. I'm measuring it with respect to 180. Understand that. Okay, so this was 180 degrees. So plus 30. So I'm measuring it with respect to 180. So there must be no change. So cos should remain cos, but you need to be careful about this angle. It is in the third quadrant, and in the third quadrant, all silver T. Tan is positive, so the answer will be negative. Hence, I should put a minus sign. Minus sign is important. Forget the 180, put only 30. So cos 30 is minus root 3 by 2 again. Minus root 3 by 2 again. So this is how you find the sine, cos, tan of any single angle that you have. Okay. Now I think any angle that I give you, you'll be able to find the sine, cos. The main purpose of this lecture is you should be able to apply while solving the problem. In NEET, no question will come, find cos of 210. You will never get a question. You open any PYQ, you will not get any question directly on any of the formulas that I have taught you over here. Whatever I have taught you here directly you will never get. It will be a part of a problem, a step of a problem. And without that step, you will not be able to solve the problem. Okay, understand that. So solo questions will not come from whatever I have taught you today. Nobody is going to ask you length of the arc formula. It will be a part of a problem. Maybe there is a wire of some radius bent at an angle. That length of the wire will be needed for finding the resistance. Who knows? But this is why this is called as basic math, because it is used everywhere throughout physics. And that's how we have completed this particular class. Okay, so I hope you enjoyed this lecture. I hope you learned a lot from this lecture. We have completed the geometrical aspect. Next class, if you want, spam in the comments, or else I will not take it, or else I will take my own chapter. So guys, I want everybody putting it up in the comments that you enjoyed and which topic you want next. And preferably, I think that we should probably do derivatives and integration based off questions. How about that? Derivatives and integration, or something like that. If you want, please let me know. I will definitely take it up. Okay. Thank you so much, my dear lovely warriors. I hope you enjoyed. Smash the like button right now to show and extend your support to the all the students who want to learn in English. For this, we have made this channel. Okay. So make sure you extend the support by smashing that like button and subscribe so that you do not miss any of the classes of physics, chemistry, biology. Cool. Bye bye. Captain Shreyas signing off. Hasta la vista. Take care.